how lose of types of covalent bond. These questions I have discussed with you in previous class. Electron dot structure also I have discussed how to form electron dot structure, which is also known as Lewis structure. Then with the help of few examples, I discuss how this electron dot structure or sharing of electrons takes place, which results in the formation of covalent bond. These examples we have discussed in previous class. Now let's move on to the next topic, which is physical properties of organic compounds. First of all, we need to understand what are these organic compounds and why we call this carbon as an organic compound. Because people believe that this carbon is present in plants and animals. So we'll get it organically, we'll get it from nature. So this carbon is present in plants and animals. That's why we call it as an organic compound. And these most of the organic compounds, they have very low melting and boiling point, and they have very weak forces of attraction. And why they have weak forces of attraction, you have studied in 9th standard as well. So I'll just sharp your memories. Due to this strong this large intermolecular forces of attraction, they have weak force. So that's why these organic compounds, they have low melting and boiling point, they have weak forces of attraction, and they are considered to be poor conductors of electricity. Because if we want to conduct electricity, free electrons should be there. But in this carbon, as I told you, they share electrons with the other elements. And due to this sharing, they'll not have any free electrons. So due to the absence of these free electrons, they are poor conductors of electricity. But the different allotropes of carbon are there. See, I'll discuss about these allotropes in detail later. So first, let's consider allotropes of carbon. What are allotropes? How can we say that this element exists in an allotrope form? See, if an element exists in nature more than two forms, two or more than forms, so we say that this process is known as allotropy, and the substances which are present in the nature, they are known as allotropes of that element. Suppose we'll take an example of this carbon, which is a very unique element, and this carbon exists in nature in different forms, and that process is known as allotropy, and those forms of carbon are known as allotropes. Now, carbon mainly exists in three forms in nature: diamond, graphite, and Buckminster fullerene. The diamond, which is the best friend of every woman. So diamond is the main allotrope of carbon, graphite is the main allotrope of carbon, and then we have Buckminster. So these are the three forms of carbon which are found in nature. If we look at first allotrope, which is diamond, so this carbon, as I told you, in one carbon lined up or combined with other four carbon atoms. If we look at the structure of this diamond, so it is, it share its electron with another carbon. So here it make a bond. As you can see, it is compactly packed. In case of diamond, this is compactly packed, and this kind of arrangement is present in diamond. Due to the presence of this arrangement in diamond, it is very rigid and it does not have any free electrons to move. That's why diamond is quite known as hardest substance but poor conductor of electricity. As you can see, it is bounded with other carbon atoms. Similarly, this also bounded with four other carbon atoms. So as you can see, it forms a lattice-like structure. So, due to this kind of structure, diamond considered to be a poor conductor of electricity. And we, because of this high refractive index, although we'll study about properties of diamond in detail, so, but we are aware of this diamond we use in jewelry. So these are the certain properties of allotrope of carbon, diamond. Then we have graphite. In graphite, each carbon is bonded to other three carbon atoms, and it means it forms a layer-like structure. And as a result of this layer-like structure, as you can, I'll just show you, one, two, it forms structure like this. It forms a layer-like structure like this. So due to this slippery nature of this graphite, it has some electrons, so that's why it's considered to be a good conductor of electricity, because it combines with three carbon atoms and one is free to move. So due to the presence of this free electron, it is a good conductor of electricity, and due to this slippery nature, we use it as a lubricant in machines. Then next is Buckminster fullerenes. It is an allotrope of carbon which contains these 60 carbon atoms, and it is quite dark solid at room temperature, and it forms a spherical molecule. So these are the three main allotropes of carbon: diamond, graphite, and Buckminster fullerene. It's a 1 mark question. Name the allotropes of carbon. And you have to write answer diamond, graphite, and Buckminster fullerene. Now, in this chapter, we'll study about versatile nature of carbon. We'll study about hydrocarbons, isomerism, homologous series, functional groups, nomenclature of functional group. So, these are the very important topics which I'm going to discuss in detail one by one. So first, I'll focus on versatile nature of carbon. As I told you, carbon is present everywhere. Although it is present in a very small percentage, which is 0.03 percentage in atmosphere. But in this small percentage also, it acts like it behaves like a wonder. So it shows some wonder. It gives some magic in the nature. So due to this versatile nature of carbon, we use it in different forms. This carbon is present in food, this carbon is present in fuels, the carbon is present in hydrocarbons. Hydrocarbons means when hydrogen combined with carbon. So it forms n number of this compounds. So that's why we say that this carbon is so much versatile in nature. And there are two properties of this carbon, which is catenation and tetravalent. So before I'll go to this catenation and tetravalent nature, I'll discuss diamond and graphite in detail. See, if we talk about this diamond, as I told you, one carbon combines with four. One carbon combines with four carbon atoms, and as a result, it forms tetrahedral, or we can say 3D kind of structure. And in this form, it forms structure like this. You can see this kind of structure is present in diamond, and it has a high refractive index. As a result, when we cut diamond, it reflects some large amount of light. That's why it is quite very shiny in nature, and we use it in jewelry. We use diamond for cutting purposes also. For cutting glasses in factories, we use this diamond. So these are the properties of diamond. It has very high melting and boiling point due to this rigid structure. This is due to this complex structure or 3D structure. And if we talk about graphite, as I told you, this carbon is free, which makes it good conductor of electricity. Due to this slippery nature, we use it as a lubricant, and this graphite is grayish black in color. Apart from this, its weight is quite lighter than that of the diamond. So these are the properties of graphite, and it is insoluble in common solvents. So these are the properties of diamond and graphite, which is considered to be most important allotropes of carbon. Now let's move on to important properties of catenation. The catenation is the property in which an element links with the other element. Self-linking property. It means one element linked with the other element of the same kind. So it has the tendency to link with any other element of the same group. So if we talk about this carbon, which I am saying, it is a very unique in nature. If we look at this catenation property, this carbon has the tendency to link with another carbon, and this linking, self-linking property of carbon is known as catenation, which results in the formation of covalent bond. As you can see, the bond which is formed between these carbon are known as covalent bond. And this property is known as catenation. Due to this property, see, as I told you, this carbon is very small in size. And due to this small in size, it is easy for this carbon to link with any other carbon. And the bond which is formed between one carbon and another carbon, which is known as covalent bond, it has a very great strength. It means it is quite strong due to its very small size. Although silicon also has 4 atoms in its outermost shell, but it is not showing this catenation property. But because the size of silicon is more than that of the carbon. So that's why only carbon shows this property of catenation. Now, okay, write in the comment section why carbon cannot lose or gain electrons. Because this point I have discussed in previous class, why carbon cannot lose or gain electrons. Those who knows the answer, write in the comment section. Now, if carbon combined with any other carbon, it forms, different type of bond. So, if carbon combines with hydrogen or with, carbon only, so it results in the formation of different type of structure. Here in front of you, if you see here, carbon combines with this carbon, and similarly, this carbon combines with hydrogen. So, those compounds in which hydrogen and carbon both are present, we call them hydrocarbons. Like methane, ethane, then we have butane, then propane, pentane, hexane. So there are so many hydrocarbons are there. Ethanol, methanol, in which both hydrogen and carbons are present. So those are known as hydrocarbons. So if you look at this structure, 3 carbons are here. Means 3 carbons are here, and each carbon makes a bond with one hydrogen. This combines with this one and this one. Each carbon, if you look at the electronic configuration of carbon, which is 2, 4. It means it has 4 valence electrons. It has 4 electrons in its outermost shell. So these 4 electrons makes covalent bond with each element. Here you can see this is 1, 2, 3, 4. So each carbon engage itself with other element to make that bond, and this kind of bond is known as covalent bond. Again, if you look at this carbon, here also 1, 2, 3 and 4, then 1, 2, 3, 4. So this is formula of propane. Then we have another hydrocarbon which is butane. If we look at this carbon, 1, 2, 3, 4. So it means all the 4 electrons which are present in its outermost shell combines with 3 hydrogen and 1 carbon. Here it combines with 2 carbon and 2 hydrogen. Again with this carbon, it combines with 2 carbon, 2 hydrogen. It means each and every electron which is present in the outermost shell is engaged with some other element. And if you look at this, combines with 1, 2, 3 hydrogen. So this is known as catenation. Okay. Now, catenation when combined, see, it has the tendency to combine with another carbon. So this self-linking property is known as, which results in the formation of different type of structures. And first, this kind of chain is known as straight chain. As you can see here, straight chain is there. Then we have branch chain. Branch chain means it is not present in a single line. So in this case, if you look at this example, 2-methyl propane, how can we give this name? We'll discuss later. That is known as IUPAC naming. So I'll discuss that part in detail in later. Now, look at this example. Here you can see 1, 2, 3, 4. 4 carbons are there, but only 3 are present in straight line, and 1 forms a branch chain. Branch means it forms some branch structure. It is emerging from 1 carbon. If you look at this structure, this carbon 1, 2, 3, 4. Again, if we look at this carbon 1, 2, 3, 4. 1, 2, 3, 4. So here also each and every carbon is engaged with any other element to form a bond. Now 1 carbon emerging from the another carbon, this is known as branch. Here you can see this is combined with this carbon. So here 1, 2, 3. And so these kind of structures in which not linear structure is present, so we say that it's a branched chain structure. Then we have another example which is 2,2-dimethyl propane. So see, this is also very complex kind of. Here this carbon is making bond with these hydrogen and 1 carbon. So here 2 carbons are emerging from here. Now this carbon also make bond here, and this can also. So see the structure of this complex carbon. It's a it do wonders. How can it make such a structures? That's why we call it a magic element. As you can see, n number of compounds can be formed from this carbon. Now it, apart from straight chain, branch chain, it forms rings also. And how can it form rings? Let's look at the examples of these ring kind of structures. See, this is cyclohexane. Hexane means 6. It means 6 carbons are present. 1, 2, 3, 4, 5, 6. And each carbon combines with other carbon due to this catenation property, and which results in the formation of rings type of structure. And if we look at this cyclobutane, it also form a ring like structure. So these are the examples of different kind of structures formed by carbon, like straight chain, branch chain, and ring structure. Now next property is tetravalent nature. Tetravalent nature means if we are saying carbon atomic number is 6. Now write down in the comment box what is the electronic configuration of carbon. If you know the answer, write in the comment section what is the electronic configuration of carbon. It is 2, 4. It means it has 4 electrons in its outermost shell, and it is known as tetravalent. Tetra means 4, valent means valence. So it has 4 electrons in its outermost shell, and this nature is known as tetravalent nature. So due to the presence of 4 electrons in its outermost shell, It is capable of forming with 4 other atoms of carbon or with other heteroatoms. Now, this due to this property, one more example. See, there is one term comes heteroatom. There are two terms: homoatom and heteroatom. Homoatoms are those which are made up of only one kind of atom. For example, homoatoms examples are H2, then Cl2, then O2. And if we are talking about heteroatoms, that is CH4, NH3, HCl. So these are the examples of homoatom. It means it contains same number of atoms or same type of atom. But in heteroatoms, they have different type of atoms present. So this is the difference between homo and heteroatom. So due to this property of tetravalent nature, or we call it tetravalency. Call it tetravalency. Tetravalency of carbon. Due to this tetravalency of carbon, it achieves inert gas configuration, and as a result of which it results in the formation of different type of bonds. Carbon is like this, okay. It has a tendency to combine with other atom or heteroatoms and to form different kind of bonds, whether it is a single bond, triple bond or double bond. And how these bonds are there? Okay, now first I'll discuss about hydrocarbons. Single bond is like this, double and will represent triple bond like this. So these are the triple bonds, single or double or triple, right? So these are the different types of bond which are formed by the carbon due to this tetravalent nature. Now let's look at the hydrocarbon. As I told you, the compounds which contain carbon and hydrogen. As if you look at the spelling of this hydrocarbon, from this name you'll get an idea what is present in it. Hydro means hydrogen and carbon means carbon. So if compounds contain carbon and hydrogen, we call them hydrocarbon. And examples of such kind of hydrocarbons are methane, ethane, ethene, ethine, or these many more examples are there. Butane, propane. There are so many examples. And we segregate or we classify these hydrocarbons into different categories. Those are structural hydrocarbon, or saturated, unsaturated and aromatic. So we'll discuss about these hydrocarbons one by one in detail. First is saturated hydrocarbon, then we have unsaturated, and finally we have aromatic. So in saturated, generally alkanes can come. Formula of alkane is CnH2n. And formula of alkenes and alkynes, which are unsaturated type of hydrocarbons, CnH2n, and alkynes is CnH2n minus 2. You need to learn these formulas. Aromatic hydrocarbons. What are these kind of hydrocarbons? We'll discuss in detail one by one. So till here, I think it is clear. Now, what kind of question can come on the basis of this topic? The very important question which comes in exam is on the basis of this category. And children, remember from this chapter, 1 mark question, 2 mark question, 3 mark question, 5 mark question in exam. So this is extremely important chapter, and each and every point is very important. You need to go through each and every concept in detail. So whatever I have done till now, what kind of question can come in the exam? First is like catenation. On the basis of this catenation, question can come in exam. What is a unique property of carbon? Or what do you mean by term catenation? And why this catenation takes place? An answer for this question is, if the question comes, define catenation. So you need to write the self-linking property of an element, mainly carbon atom, through covalent bonds to form long, straight branch and rings of different sizes is called catenation. And why this catenation occurs? And the reason for this is small size of the carbon atom and the great strength of the carbon-carbon bond. Or question can come, write any two versatile nature of carbon, and the answer is catenation and tetravalent nature. Or write down two main allotropes that I have already discussed with you. Or what kind of chain is formed due to this property of due to the unique property of carbon. So answer is, it can form double chain, double or single or triple bonds, and it can form straight chain structures, ring structures or branch structure. Our question can come in 1 mark. Give an example of any branch chain structure. You can give any example, although more examples are there. Or question can come in 1 mark. Give an example of straight chain type of carbon. So then you have to draw this structure and write the name. Now first is saturated hydrocarbon. See, in this saturated hydrocarbons are those in which carbon atoms are linked together by covalent bond. So saturated hydrocarbons, right here, saturated hydrocarbons are those in which carbon atoms are linked by single bond. If you look at the examples of these saturated hydrocarbons or type which come under this saturated hydrocarbon is alkane, and the formula is CnH2n plus 2. Here N is the number of carbon atom. If carbon atom is 1, so for 1 we use meth, carbon atom is 1. For 2 we use eth. For 3 we use prop. For 4th we use but. I'll explain how we can give this IUPAC naming to them. So just remember, if carbon atom is 1, we'll use meth, then 2 for eth, then for 3 we use prop, and for 4 we use but. And the formula for alkane, which is a saturated hydrocarbon, in saturated hydrocarbon, the carbon atoms are connected by a single bond. It means they are linked together by single bond. And here are the examples. If you look at the example of methane, as I told you, if carbon atom is 1, according to this formula, CnH2n2, in place of n, I'll just put 1 only, which is number of carbon. Now solve this and we'll get 2 plus 2 is CH4, which is the formula of methane. And how we can represent this methane? CH, H. As you can see, only single bonds are present. And now let's take an example of ethane also. Now if N is equal to 2, it means number of carbon atoms are 2. So find out the formula of this compound if N is equal to 2. Write in the comment section. If N is equal to 2, then according to the formula, simple to write. In place of N, just simply write 2. H2 into 2 plus 2. So C2 H4 plus 2, then we'll get C2H6. Easy. Now, how can we write formulas of these hydrocarbons? So, it is mentioned here. So, it depends on the number of carbon atoms. Now, let's move on to carbon atom 3. So, now, who will tell what is the formula of carbon atom 3 according to the formula? So, solve it along with me. In place of n, what should we write? We'll write only 3. So, it's C3H2 into 3 plus 2. C3, 6 plus 2, C3H. Now, these are the formulas of different hydrocarbons. And how can we represent them? Look at these structures. Ethane, C2H6, 1, 2, 3, 4, 5, 6. Propane, C3H8. So, C3 is here, and with each carbon, hydrogen are linked up, and this carbon is linked up with this. It is easy to write their structure. This is linear structure, or we can say it is a straight line structure. So, I hope this formulas of writing saturated hydrocarbons, or we can say alkanes, it's very easy for you. Just write down the number of carbon atoms. Or let's take one more example of butane. Solve it. If n is equal to, see, I'm solving each and every hydrocarbon for you, so that it's easy for you to solve these kind of formula. In place of n, I'll write 4. So 4 plus 2. So C4, 8 plus 2 equal to C4H10. How can we represent this propane, sorry, butane? 1, 2, 3, and 4. So 4 carbon atoms are there. Just link one hydrogen with each carbon, so that with each electron, rather, I can say, so that it here you can see 1, 2, 3, 4 carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the formula, structure formula. Butane. Now, I think it's easy for you. How can you write the formula? It's extremely important topic, and you should know how to write the structures of these alkanes. But for this, you have to learn these formulas. And the more you will do practice, more you can learn. This is extremely important, and question can come on the basis of this topic in generally in 1 mark or 2 mark. Like draw the structural formula of ethane, methane, propane, or butane. Any hydrocarbon can be given, or they'll ask you write down the formula for methane. If you know this formula of alkane, you can easily make the formula of other hydrocarbons. So this is how you can write the structure formula and simple formula for these hydrocarbons which are in alkanes. As you can see, anes. It means for each and every hydrocarbon we are using ane. So this first, it represents number of carbon atoms, and it shows type of hydrogen. Okay, so if 1 carbon atom is present, we use meth. If 2 are present, we use eth. 3 are present, we use prop. And if 4 are present, we use but. These tell us the number of carbon atoms, and last 3 numbers shows whether they are alkanes, alkenes, or alkynes. So these are the different kind of hydrocarbons, or we say that saturated. Then we have unsaturated hydrocarbon. Unsaturated contains alkenes. I told you, see, if you look at this, alkenes and alkynes, they come under the category of unsaturated. As in case of alkanes, we have one particular formula. For alkenes also we have formula which is CnH2n. I'll write here CnH2 so that it is easy for you to understand. Now, in this, if you'll see, two carbon atoms are connected by double bond. So in alkenes, double bonds are there. In unsaturated carbons, one carbon atom is linked up with other by double bond or triple bond. So it is different from that of saturated hydrocarbon. In saturated, only single bond is there. In unsaturated, double or triple bonds are there. Right? So if we look at this example of alkenes in which double bond is present, starts with ethene. So if carbon atom, because only two bond means, it means two carbon atoms involved. So according to this, if N is equal to 2, it forms C2, and then first I'll write the formula H2. So it becomes C2H4. So it means two bonds are present and 4 hydrogen are associated. This is how you can write formula for ethene. Okay, this is how you can write, or you can represent it like this as. Now, then we have butene, propene. It is propene, and it is butene. If N is equal to 3, then how can you write? If N is equal to 3, C3H2 into 3. We'll write C3H6. Okay. Now, as you can see, C3, 1, 2, 3, it means 3 carbon atoms are present and 6 hydrogen. 1, 2, 3. Sorry, this is 1, 2, 3, 2, 3, 4, 5, 6. I'll just remove it. 1, 2, 3, 4, 5 and 6. So this is how will you write. Here it is missing. Just write 1, 2, 3, 4, 5 and 6. So 6 hydrogen. This is the way how you can write their formulas and structures are. Now if butene 4, it means it has 4 carbon atoms. So C4H2 into 4, C4H8, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Now you can see 1, 2, 3, 4, 5, 6, 7, 8. So here, this is the formula for butene. So I hope till here it is clear how can we write these formulas for saturated and unsaturated hydrocarbons. So alkenes I'll do later. So till here, now what is your homework? So you need to learn formulas for these alkanes and alkenes and jot down the difference between diamond and graphite. In next class, I'll discuss those points with you. What are the differences between different allotropes of carbon, how they are different from each other, and what are the formulas of alkanes and alkenes, and how can you write their structural formula of the different hydrocarbons. So these kind of questions can come in exam. They write down the structural formula of the given hydrocarbons, and then you need to draw these kind of structures, and if you know the formula you can easily write down their structure. So children, from next week we have our videos will come on the app only. So please subscribe our channel and download our app. There you'll get all the videos So please be hurry and download this app of the Stuti Academy on the Google Pay and Google from the Google Play Store, and then you'll get ample of videos of each and every topic. So till then, goodbye and take care, and learn as much as you can. Go through each and every topic. As I told you, this is extremely important chapter according to exam point of view. Questions definitely come from this topic. 1 mark question, 2 mark question, 3 mark question, or 5 mark. So revise all these topics in detail so that it is easy for you. So again, I'm repeating. So please download our app, and you'll get ample of videos there, and you'll get assistance from the teachers. We have highly qualified teachers who will assist you and are ready to solve all of your queries. So till then, goodbye and take care. So these topics, just go through it. And those who have doubt in any of the topic, they'll ask and write in the comment box, so that in next class I'll take your doubts. Whatever